வணக்கம். 9th Standard Science English Medium Unit 3 Fluids Textbook Exercises. Choose the correct answer. The size of an air bubble rising up in water. Answer: increases. The size of an air bubble rising up in water increases. Second question. Clouds float in atmosphere because of their low, option A, density. Clouds float in atmosphere because of their low density. Third question. In a pressure cooker, the food is cooked faster because, option B, increased pressure raises the boiling point. Increased pressure raises the boiling point. Fourth question. An empty plastic bottle closed with an airtight stopper is pushed down into a bucket filled with water. As the bottle is pushed down, there is an increasing force on the bottom. This is because. Answer C. Pressure increases with depth. Pressure increases with depth. Fill in the blanks. The weight of the body immersed in a liquid appears to be less than its actual weight. Answer: lesser. The weight of the body immersed in a liquid appears to be lesser than its actual weight. Second question. The instrument used to measure atmospheric pressure is dash. Answer: barometer. The instrument used to measure atmospheric pressure is barometer. Third question. The magnitude of buoyant force acting on an object immersed in a liquid depends on dash of the liquid. Answer: density. The magnitude of buoyant force acting on an object immersed in a liquid depends on density of the liquid. Fourth question. A drinking of straw works on the resistance of dash. Answer: air pressure. A drinking straw works on the resistance of air pressure. State whether true or false. If false, correct the statement. First question. The weight of fluid displaced determines the buoyant force on an object. Answer: true. The shape of an object helps to determine whether the object will float or not. Answer: false. Correct statement is not shape, it is density. The density of an object helps to determine whether the object will float. Third question. The foundation of high-rise buildings are kept wide so that they may exert more pressure on the ground. Answer: false. Correct statement is the foundation of high-rise buildings are kept wide so that they may exert less pressure on the ground. Fourth. Archimedes principle can also be applied to gases. Answer: true. Archimedes principle can also be applied to gases. True. Fifth question. Hydraulic press is used in the extraction of oil from oil seeds. Answer: true. Hydraulic press is used in the extraction of oil from oil seeds. True. Match the following. Here column 1 and column 2 are given. In column 1, density 1 gram weight, Pascal's law, pressure exerted by a liquid, lactometer are given. In column B, HPG, milk, mass by volume, pressure 980 dyne are given. We have to match it correctly. Let us see the answer. Answer: density, mass by volume. Density, mass by volume. 1 gram weight, 980 dyne. Pascal's law, pressure. Pascal's law, pressure. Fourth one, pressure exerted by a fluid, H rho G. Pressure exerted by a liquid, H rho G. Lactometer, milk. Lactometer, milk. Answer in brief. On what factors the pressure exerted by the liquid depends on? Answer: pressure exerted by a liquid at a point is determined by depth h, density of the liquid rho, acceleration due to gravity g. Depth, density of the liquid, acceleration due to gravity. Why does a helium balloon float in air? Helium is denser than ordinary air and this gives helium buoyancy. Hence, helium balloon floats in air. Third question. Why is it easy to swim in seawater than in river water? Answer. Seawater's density is more than the density of river water because seawater contains dissolved salts. Due to high density, buoyant force increases. So, it is easy to swim in seawater than in river water. Fourth question. What is meant by atmospheric pressure? Answer. An air occupies space and has weight. It also exerts pressure. This pressure is called atmospheric pressure. State Pascal's law. Answer. The external pressure applied on an incompressible liquid is transmitted uniformly throughout the liquid. Answer in detail. With an appropriate illustration, prove that the force acting on a smaller area exerts a greater pressure. Answer. Stand on loose sand. Your feet go deep into the sand. Now lie down on the sand. You will find that your body will not go that deep into the sand. In both the cases of the above activity, the force exerted on the sand is the weight of your body, which is the same. The force acting perpendicular to the surface is called thrust. When you stand on loose sand, the force is acting on an area equal to the area of your feet. When you lie down, the same force acts on an area of our whole body, which is larger than the area of our feet. Therefore, the effect of thrust depends on the area on which it acts. The effect of thrust on sand is larger while standing than while lying. The force per unit area acting on an object concerned is called pressure. Thus, we can say thrust on an unit area is pressure. Pressure is equal to thrust by area of contact. For the same given force, if the area is large, pressure is low and vice versa. Describe the construction and working of Mercury Barometer. Answer. Mercury Barometer uses the instrument used to measure atmospheric pressure is called barometer. Construction. A mercury barometer, first designed by an Italian physicist Torricelli, consists of a long glass tube that is closed at one end, open at the other, filled with mercury and turned upside down into a container of mercury. This is done by closing the open end of the mercury filled tube with the thumb and then opening it after immersing it into a trough of mercury. Working. The barometer works by balancing the mercury in the glass tube against the outside air pressure. If the air pressure increases, it pushes more of the mercury up into the tub, and if the air pressure decreases, more of mercury drains from the tube. As there is no air trapped in the space between mercury and the closed end, there is vacuum in that space. Vacuum cannot exert any pressure. So, the level of mercury in the tube provides a precise measure of air pressure, which is called atmospheric pressure. Third question, how does an object's density determine whether the object will sink or float in water? Answer, whether an object will sink or float in a liquid is determined by the density of the object compared to the density of the liquid. If the density of a substance is less than the density of the liquid, it will float. For example, a piece of wood which is less dense than water will float on it. Any substance having more density than water, for example, a stone, will sink into it. Fourth question, explain the construction and working of a hydrometer with diagram. Answer, hydrometer uses a direct reading instrument used for measuring the density or relative density of the liquid is called hydrometer. Hydrometer is based on the principle of flotation. That is, the weight of the liquid displaced by the immersed portion of the hydrometer is equal to the weight of the hydrometer. Working. Hydrometer consists of a cylindrical stem having a spherical bulb at its lower end and a narrow tube is upper end. The lower spherical bulb is partially filled with lead salts or mercury. This helps hydrometer to float or stand vertically in liquids. The narrow tube has marking so that the relative density of a liquid can be read directly. The liquid to be tested is poured into the glass jar. The hydrometer is gently lowered into the liquid until it floats freely. The reading against the level of liquid touching the tube gives the relative density of the liquid. Assertion and reason type questions, mark the correct answer as. 4 options are given. We have to choose the correct option. Option A, if both assertion and reason are true and the reason is the correct explanation of the assertion. B, if both assertion and reason are true but reason is not the correct explanation of assertion. Option C, if assertion is true but reason is false. Option D, if assertion is false but reason is true. First question, assertion. To float, body must displace liquid whose weight is equal to the actual weight. Reason, the body will experience no net downward force in that case. Here, assertion is true and reason is also true. Reason is the correct explanation of assertion. So here answer is option A. If both assertion and reason are true and the reason is the correct explanation of assertion. Second question. Assertion. Pascal's law is the working principle of a hydraulic lift. Reason. Pressure is thrust per unit area. Here 4 options are given. A. If both assertion and reason are true and reason is the correct explanation of assertion. B. If both assertion and reason are true but reason is not the correct explanation of assertion. C. If assertion is true but reason is false. D. If assertion is false but reason is true. Here assertion is true and reason is also true, but reason is not explaining correctly the assertion. So here answer is option B. If both assertion and reason are true, but reason is not the correct explanation of assertion. Numerical problems. Question number 1. A block of wood of weight 200 gram floats on the surface of water. If the volume of block is 300 centimeter square, calculate the upthrust due to water. Solution. Volume of block V is equal to 300 centimeter cube. 1 kilogram force is equal to 1 kg. F is equal to 9.8 meter per second square. Weight of block is equal to 200 gram is equal to 0.2 kilogram. F is equal to 0.2 into 9.8 is equal to 1.96 Newton. Block is floated in the water. It is equated by upthrust force. Therefore, the upthrust due to water is equal to 1.96 Newton. The density of water is 1 gram centimeter minus 3. What is the density in SI units? Solution. Density of water at 4 degrees C is equal to 1000 kilogram meter minus 3. 1 gram is equal to 1 into 10 power minus 3 kilogram. 1 centimeter is equal to 1 into 10 power minus 6 meter. The density of water in SI units is equal to 1 into 10 power minus 3 by 1 into 10 power minus 6. We get 10 to the power minus 3 into 10 power 6 is equal to 10 to the power 6 minus 3 is equal to 1000 kilogram per meter cube. Therefore, density of water in SI unit is equal to 1000 kilogram per meter cube. Density of mercury is 13,600 kilogram meter minus 3. Calculate the relative density. Relative density is equal to density of mercury by density of water. Relative density is equal to density of mercury is 13,600 kilogram meter power minus 3 by density of water is 1000 kilogram meter minus 3. If we simplify, we get 13.6. Therefore, relative density is equal to 13.6. Relative density has no unit. Fourth question. Calculate the apparent weight of wood floating on water if it weighs 100 gram in air. Answer. If a body of mass 100 gram is floating in water, it will experience an upthrust due to water displaced by immersed part of the body. For a floating body, upthrust will be equal to the weight of the body. Therefore, the apparent weight of the body will be 0. Apparent weight of the body is equal to weight of the body minus upthrust. Here weight of the body is 100 gram and upthrust is 100 gram. So 100 gram minus 100 gram is equal to 0. Higher order thinking skills. Question number 1. How high does the Mercury Barometer stand on a day when atmospheric pressure is 98.6 kPa? Here we have given atmospheric pressure 98.6 kPa. Atmospheric pressure P is equal to H rho G. H height, rho density, G acceleration due to gravity. We have given atmospheric pressure P 98.6 kilopascal is equal to H into 13,600 into 9.8. Rho density of mercury is 13,600. G is equal to 9.8. We have to substitute. H is equal to P by rho G. H is equal to 98.6 by 13,600 into 9.8. If we simplify, we get H is equal to 98,600 by 1,33,280 is equal to 0.7397. Therefore, height of the mercury H is equal to 0.7397 millimeter or 740 millimeter. Second question. How does a fish manage to rise up and down in water? Answer. To reduce its overall density, a fish fills the bladder with oxygen collected from the surrounding water through the gills. In this case, the forces of buoyancy and gravity cancel each other out and the fish stays at that level. Most fish rise and sink using this method. Third question. If you put one ice cube in a glass of water and another in a glass of alcohol, what would you observe? Explain your observations. Answer. The density of ice cube is lesser than density of water. So it floats in water. But the density of ice cube is greater than the density of alcohol. So it sinks in alcohol. Fourth question. Why does a boat with a hole in the bottom would eventually sink? Answer. The water winds and rushes into the boat. That means the boat is heavier. So it starts to sink, trying to displace more water. But the water keeps coming in because the hydrostatic pressure at the hole is always higher than the atmospheric pressure, pushing down on the surface of the water in the boat. Thank you.